So adding and subtracting rational expressions. The deal with adding and subtracting fractions in general is that we have to have a common denominator. So again, this is one of those things I feel like you guys have gotten comfortable with just doing in a calculator and maybe not understanding why you do what you're doing when you're adding and subtracting fractions. So that's what I want to start with. Okay? So if I gave you two fractions, what am I looking for here? There we go. So let's say maybe 2/15 plus 1/6. I think that sounds like a good start. Careful with the door. Alright, I need to add those two fractions together. So the first thing I'm going to do when adding those two fractions together is get a common denominator. What's the common denominator between 15 and 6? How would we go about figuring that?
Divide it.
What do you mean by divide
Try
it?
to simplify it. Get it to something that's the same number.
Okay, so basically the idea is you're trying to find the least common denominator. If I counted by 15s and I counted by 6s, what would the first number be that I would come up with, right? So that's kind of how you were explained how to do a common denominator before. I actually want to factor this and show you guys mathematically why that works. So 15, factor out 15 for me. 5 and 3. Factor out 6 for me. 2 and 3. So what we're going to have to do to get a common denominator, the common denominator between these two would be 30, right? If I count by 15s and I count by 6s, the first number that they share is a 30. Y'all with me? Okay. Mathematically, the way that you get that is you're going to take one of every factor of the denominators. If there's a repeat, you don't take the repeat. Okay? So I'm going to take a 5. I'm going to take a 3. I'm going to take a 2. I already have a 3. I don't need another 3. We multiply all those together. What is 5 times 3 times 2?
30.
That's where we get the common denominator of 30. Okay, so mathematically, that's why you do what you do.
And then would you just add up the
So then what you have to do for the other part, the common denominator was 30. What do I have to multiply 15 by to get 30?
2.
So I have to multiply the numerator and denominator by 2. So that gives me a numerator up here of 4. Okay, the common denominator over here was a 30. What do I have to multiply 6 by to get to 30? I have to multiply by 5. So you have to multiply the numerator by 5 as well. 1 times 5 is 5. And what we were doing with these two fractions was adding them. So I'm going to add the numerators now.
Could you just
So we end up with 9 over 30, which, of course, if it will reduce, we would reduce that. Okay? So 9 and 30 are both divisible by 3. That would give me 3 over 10. Do you guys kind of follow that process with the numbers? Did that make sense with the numbers? Okay. So we've got to kind of do that same process, but we're going to be doing them with rational expressions today. Okay. So here's your steps. For those of you guys who like the verbal steps written out, here's your steps. You're going to factor the numerator and the denominator, and of course, if one of the fractions reduces, you'll just want to reduce the fraction down. Determine the least common denominator. So that's where you're taking one of every factor of the denominators. Rewrite each fraction as an equivalent fraction with the denominator. That was the whole multiplying the top and the bottom by the same thing. And then you're going to add or subtract the numerators, simplify or factor the new numerator, and cross out any common factors. Okay, so we've got a few examples here working through these today. So here's our first one. And I already put a note in here on this one. What do you notice about the two denominators on this one? Already common denominators, and that's what I wrote in here. So not a whole lot to do on these. When there's already a common denominator, all we have to do are add the numerators together. Okay, so the common denominator is 2x squared plus 9. So we're going to keep that denominator as 2x squared plus 9. So I'm just going to write a denominator of 2x squared plus 9. And then the numerator, we're just going to add these two numerators together. So x squared plus 4 plus x squared plus 5. Now because it's addition, I don't necessarily have to have the parentheses around each numerator. If it was subtraction, I would want to do this parentheses because the subtraction would distribute. Right? And And then to finish simplifying this, we would just add our like terms together in the numerator. So like terms, we have x squared and x squared, which would give me 2x squared, again, because I'm adding here. And then we have like terms 4 and 5, which would add up to 9. Denominator, we have 2x squared plus 9. Okay, so what is 2x squared plus 9 divided by 2x squared plus 9? What's anything divided by itself? 1. So this whole thing does simplify down to 1. Not always going to happen, and just gave you an example like that of what could happen. Sure. Okay. Have any questions on that one? Okay. Let's give the next one a try. Okay. If the denominators are not already common, we're going to have to make them common. We do that by finding the common factors, okay, to get our common denominator. So we're going to factor our denominator here. 3 terms. We've gotten a lot of practice in factoring over on last lesson. How do I factor when there's 3 terms? Yep, that's our hopscotch, our puzzle. Okay, top box in this case is negative 16, bottom box is 6. All right, so I need 2 numbers that would multiply to give me negative 16 and add up to 6. So what times what gives me negative 16? Do those same 2 numbers add up to 6?
8 and negative 2.
8 and negative 2. Okay. So that means this denominator is going to factor down. The numerator stays the same, 3x plus 26. The denominator is going to factor out to x plus 8, x minus 2. So all I'm doing right now is just rewriting with the factored denominator. All right, what about our second denominator? Can we do anything with x minus 2? Can I factor that out? No. It's x to the first power, or just x. There's not a GCF. I can't do anything with that one, so it's just x minus 2. And the numerator would just stay at 2. Okay. To get a least common denominator, you're going to take one of every factor that is listed in the denominators. All the denominators, you're going to take one of each. Okay, do not repeat. So if I already have an x minus 2, I'm not going to take another x minus 2. Is that making sense? Okay, so our least common denominator, we have an x plus 8. So we're going to write down an x plus 8. We have an x minus 2. So we're going to write down an x minus 2. There's already an x minus 2, so I'm not going to take another x minus 2. Did that make sense? Okay. So then what you have to do is multiply the numerators. We have to adjust the numerators for changing the denominator. So the way that I look at it for that process, what does this denominator have that this denominator is missing? Again, look at your least common denominator. What does this denominator have that this denominator is missing? Anything? Is it missing anything?
No.
Then my numerator is not going to change. So my numerator is going to stay 3x plus 26.
Okay, you're confusing me for that.
We have subtraction between the two, so I'm going to go and put my subtraction sign. Now, what is this denominator missing that this denominator has? Again, what's this denominator missing that this denominator has?
The x plus 8.
The x plus 8. There is an x plus 2. It does not have an x plus 8. So we're going to put an x plus 8. Which means I have to also put an x plus 8 up here. So my new numerator is 2 times x plus 8. So I want to add in a note for what we were kind of asking ourselves here. what is the original denominator missing that the common denominator has. Okay, and that's what we're doing down here to get these pieces that we did over here. And sometimes you're going to have to modify both denominators. Sometimes, like in this case, you only had to modify the second denominator. The second denominator was the only thing missing something. Okay, now we need to clean up the numerator. So I'm going to take that -2 and I'm going to distribute it. And I'm going to rewrite the 3x plus 26. So 3x plus 26. Okay, so the 3x plus 26 was the original first numerator. And then -2 times x is -2x. -2 times 8 is -16. On the bottom, we still have x plus 8 and x minus 2. Last piece is to add those common factors together, the common terms together. So I have a 3x that I'm going to add with a -2x. So positive 3x, -2x would give me x. Here I have a positive 26 and a -16. When I add those up, it gives me a positive 10. And on the bottom, we still have x plus 8 and x minus 2. So what I was explaining before, the bulk of the work when you're adding and subtracting fractions is going to come from getting the common denominators and then changing the numerators. Had this been an x plus 8 and not an x plus 10, you could cross those out. Okay, so just a heads up, if there's any common factors, once you add all the stuff together, you can reduce by crossing those factors out.
Same thing for x minus 2.
If it was x plus 8, and the cross them out, so what did you do that for x minus 2?
Yes, but on the top there would be a 1,
A 1.
right? If we cross everything out from the numerator, there is always a 1 left over in the numerator. Same thing for the denominator. We just don't typically write it when there's just a 1 in the denominator, right? Like 5 over 1 is just 5, so we don't typically put the 1 in the denominator. But 1 over 5, we have to keep the 1 in the numerator. Okay. All right, you guys, let's give another one of these a try then. So again, our first step, factor the denominators. So in this case here, there's just a GCF of 3. So my denominator is going to be 3 times x plus 5. That's my new denominator for this guy over here. Now what is my least common denominator? So if I factored this out to this, remember you're taking one of each factor that you see in all the denominators. Okay, 3 is a factor, so I'm going to take a 3. X plus 5 is a factor, so I'm going to take an x plus 5. The other denominator has an x plus 5. Do I take that one also? No, we're not going to repeat. We're least common denominator, so I'm taking one of each different factor. You guys with me? Okay. So that means my least common denominator is 3 times x plus 5. So then the question that I'm asking, what is this denominator missing, which is this denominator right here, that this denominator has? What is this denominator missing that this denominator has? Anything? No. If it's not missing anything, that means the numerator does not change. So the numerator is going to stay as 10. Plus. Now look at this denominator. What is this denominator missing that this denominator has?
3.
3. So I'm going to multiply by 3. That's how we would make this denominator into this denominator. So that means I also have to multiply the numerator by 3. Okay? 1 times 3 is 3. And then we would just add those common terms on top. 10 plus 3, 13. On the bottom, we have 3 times x plus 5.
I'm sorry, I'm too. Sunshine and rainbow.
Any questions? Let's try another one. Again, you start by factoring the denominators. 3 terms in this denominator, so we're going to factor it using hopscotch. Top box is a negative 16, bottom box is a 6. Huh, sounds familiar. I think we did this one already, huh? Or this polynomial. So 8 and negative 2. So that means this denominator is going to factor out to x plus 8 and x minus 2. So we're not using this denominator anymore, we're using this denominator. So now let's get the LCD, the least common denominator. Take one of every factor from the denominators. We have an x plus 8. We have an x minus 2. We already had an x plus 8, so I'm not going to take another one. So my LCD for this would be x plus 8, x minus 2. So we are subtracting these two fractions. I'm going to write my LCD here, x plus 8, x minus 2. And then what we're asking, what is this denominator missing that this denominator has? What is this denominator missing that this denominator has? Anything? Nothing. That means my numerator does not change. We leave it as 5x plus 2. I'm going to put parentheses around this one because we're subtracting on this one. Minus. What is this denominator missing that this LCD has? What is this denominator missing that this denominator has? It's missing an x minus 2. So we're going to put in an x minus 2 here, which means I'm going to put in an x minus 2 here. So that makes this new numerator 4 times x minus 2. All right, keeping my denominator as x plus 8, x minus 2. On my numerator, I have the 5x plus 2 from the first numerator. And again, we're going to distribute that negative 4 into that second factor. So negative 4x and then plus 8. Again, denominator is still x plus 8, x minus 2. And now we're going to find our common terms and add them together. We have a 5x minus a 4x, which will just be x. We have 2 plus 8, which is 10.
Literally the exact same answer.
Same answer, yeah. Not sure why this added example. All right, let's see what else we can find. We do have to factor both denominators this time, so this will be a good one for us to focus on. Okay. So here, 3 terms. We factor 3 terms using hopscotch. Top box is a negative 2, bottom box is a 1. So I need 2 numbers that will multiply to give me negative 2, but add up to 1. 2 and negative 1. So that means this denominator is going to factor out to x plus 2, x minus 1. So we're not focused on this denominator anymore, we're looking at this guy. All right, now let's factor this denominator. When there's only two terms, again, you have all of your factoring reminders on the back of your flip book. And when there's only two terms, we're either looking at sum of cubes, difference of cubes, or difference of squares. This is a difference, and these are both perfect squares. So this will factor out the two sets of parentheses like that. What's the square root of x squared, or what times itself gives me x squared? X times x. And then what's the square root of 1, or what times itself gives me 1? 1. We put a plus in one and a minus in the other. So again, I'm not looking at this denominator anymore, I'm looking at this denominator. Alright, so let's figure out our LCD, or least common denominator. Take one of every factor that is different. So I see an x plus 2. I see an x minus 1. And I see an x plus 1. The other factor is an x minus 1. We already have one. We're not doing another one. So that is my least common denominator. So over here, my common denominator is x plus 2, x minus 1, x plus 1. So focus on this first denominator here and our common denominator here or here. What does our common denominator have that this first denominator is missing? What's the missing factor? Okay, this one does not have an x plus 1. That means I have to multiply this denominator by an x plus 1. So x plus 1. That means I have to multiply this numerator by an x plus 1 also. Okay, again, this denominator is missing an x plus 1 out of these factors. So multiply this denominator by x plus 1, which means I multiply the numerator by x plus 1 as well. So my new numerator is going to be multiplying those two together. Okay. The way that we do that is either FOIL or box, because that's 2 by 2. That's a binomial times a binomial. So I'm going to actually write that out down here because I have a little bit of space. Remember when we multiply polynomials together, we were using the box method to try to keep us organized. X times x is x squared. X times 1 is x. 3 times x is 3x. 3 times 1 is 3. These guys are like terms, so you're going to add those together. So I'm going to write it in up here from the products I got down here. So I have an x squared. 3x and 1x gives me 4x, so positive 4x, and then plus 3. That's my new first numerator. Are you guys okay? Plus, they're asking the same question over here for this one. What is this denominator missing that our LCD has? Okay. This denominator does not have an x plus 2, so we need to multiply it by x plus 2, which means that we need to multiply the numerator by x plus 2 as well. For this one, since it's just a monomial, we can just distribute the monomial in. So positive 2 times x would be 2x. A positive 2 times 2 would be 4. Last piece on this one is just to add our common factors or common terms together. So x squared does not have any common terms. So we're just going to write down x squared. All right, it's not common with anybody, so I'm going to make it a triangle. We have a 4x and a 2x is going to give me plus 6x. And then we have a 3 and a 4 would give me 7. Denominator is x plus 2, x minus 1, and x plus 1. We need to look to see, can this factor? Because sometimes when you add two numerators together, the what you get, it's possible for that to factor. So we would hopscotch with this. What we're looking at, what times what gives me 7? What adds up to 6? That's what you would have for your hopscotch squares. What times what gives me 7? That adds up to 6. If maybe this was a -7, that would have worked. But because it's a +7, it's not going to factor. So can this factor? No, so then we know we are finished. But that is one little check that you need to make to finish your, making sure that you're simplified all the way. I think we have one more, is that correct? Last one?
And then we do.
I'm going to do one complex, and that's all I'm going to show you guys on complex. Okay? I just want you guys to be exposed to it, but it's not something I'm totally stressing about. Some of you guys will see it later, but I'm going to do one and call it good. I'll fold that in half and stick this one. How are we feeling so far? Is this making sense for you guys? You're doing okay? Alright. So last add subtract example, and then I'm going to do one complex example. We'll call it good, and then you guys can start working on your assignment for me, okay? So again, process is to factor both denominators. So again, 3 terms in this denominator, so we're going to factor it with hopscotch. Top box is a 25, bottom box is a -10. So give me 2 factors that multiply to give me 25 that add up to a -10.
X or -5 and
-5 and -5. So that means my new denominator down here is x minus 5, x minus 5.
And you can automatically.
We're not going to look at that one now. Over here, just 2 terms, what do you notice they have in common?
They have a common factor.
They have a GCF of 2.
Let's do it.
Excuse me, thanks. So if I divide 2x by 2, I'm left with an x. I divide -10 by 2, I'm left with a -5. So that means the least common denominator, you are pulling one of every factor. This little 2 is a factor, okay? It was actually a greatest common factor between 2 terms. So our LCD is going to be x minus 5 and 2. And usually when I have a monomial, I throw it into the front of the parentheses. That's why we threw that one in this way. Doesn't reduce, does it? Here's your exception to the rule. Notice how there's 2 x plus 5s in x minus 5s in this denominator. We're going to have to take a repeat in that case. I forgot that was going to happen. Because there's 2 in the same denominator, we can't reduce that denominator. I can't make that denominator any smaller than it was. Okay, so I'm going to have to take 2 x plus 5s on this one.
Oh, no.
So we're going to write in repeat because both in same original denominator. Okay. That's why we're doing a repeat on this one. Otherwise, you don't want to repeat. So our least common denominator is 2 x minus 5, x minus 5. I'm looking at this denominator and my least common denominator here. What does my least common denominator have that this guy is missing? What is this missing?
X or 2.
Okay. There's an x plus 5 and x minus 5. It is missing a 2. So we're going to multiply this denominator by 2. So I'm going to multiply this numerator by 2. So this numerator becomes 2x. What is this denominator missing that my LCD has this time?
X minus 5.
We have a 2, we have an x minus 5, we need another x minus 5. So I'm going to multiply this by x minus 5 as well. This again up here is a binomial times a binomial. We've been using the box to multiply those together. You could also use FOIL if FOIL is familiar to you. So that gives me x squared, negative 4x, negative 5x, and 20. Again, like terms diagonally here. We are subtracting, so I'm going to put a subtraction sign and then parentheses because we're going to have to distribute that subtraction in. So we have x squared minus 9x plus 20.
Math is hard.
Distribute the negative to all the terms. So I have 2x minus x squared plus 9x minus 20 over 2 times x minus 5 times x minus 5. Last piece, and I'm going to scoop this down here. Just combine any like terms, and in this case, the only like terms we have are the 2x here and the 9x here. I also like to put it in standard form, so from high to low. So the negative x squared is going to come first. Then 2x and 9x will give me 11x, and then minus 20. Denominator is 2, and then x minus 5. You might see this written as x minus 5 squared. So just a heads up with that, because there's 2x minus 5s on the bottom, you might write it like this. And it's okay if you do, it's okay if you don't. Either way is acceptable. So then we have to check, does it factor? Because our first term is a negative, I'd really like to factor that negative out and make it x squared minus 11x plus 20 over 2 times x minus 5 squared. So I'm looking for factors of 20 that add up to a negative 11. What times what gives me 20 that adds up to 11?
5 and 2. No.
So I have 1 and 20. That's not going to work, right? I can't get 11 out of that. I have 2 and 10. That's not going to work. And then I have 5 and 4. Not going to work?
1 and 10, you said
2 and 10.
Oh.
So none of those are going to work, right? Okay. So does it factor? No. So you can actually leave it as either one of these options with the factored out negative or not.
Is it okay if we just left the 2x minus 5x minus 1? For the denominator?
Yeah, you can write it out with this. Alright guys, that's it for add and subtract. I think the struggle on add and subtract is just coming up with the LCD, the least common denominator. Past that, I think everything else is pretty smooth. Do you guys have any questions on add and subtract? I'm going to do one complex just so that you guys can see that there is something out there called a complex rational. Hey, actually. Do you guys see this one on the notes? You have the whole page. I'm not going to do but just this one, so you can write it on the whole page if you need to. Everybody find this one okay? Okay. So what we have here are two fractions being added, divided by two more fractions being added. So essentially, we have two addition problems, and then we have a division problem between them. Okay, so it's kind of a combination of what we're doing today, and then what we did last class. So what I want to focus on is just adding these two fractions together. Now 1 is not a fraction, I'm going to make it a fraction, 1 over 1, plus 2 over 3x. Now what we worked on today is the common denominator. Between 1 and 3x, what would the common denominator be? So the factor here is a 1, the factor here is a 3 and an x, so the LCD is just going to be 1 times 3 times x, which would be 3x. Okay. The factor here is a 1, the factor here we have 3 and x. So just like we've done before, what is this denominator missing that this denominator has? It's missing a 3 and an x. So we're going to multiply this denominator by 3x. So I'm going to multiply this numerator by 3x. What's this denominator missing that this denominator has? We could say times 1, but is that really going to change anything? So really it's nothing.
So it's 3x first.
So our denominator for this one is 3x. Our numerator is 3x times 1, so 3x, plus 2 times 1 is 2. That's my numerator. We're going to come down here, we're going to do an LCD with this guy. This denominator is x times x. This denominator is just x. Remember, if I have a repeat in the same denominator, I have to take them both. So my LCD for this one is x times x, which is x squared. So my denominator is x squared. What is this denominator missing that this denominator has?
Nothing.
Nothing, so this stays as 2. Plus, what's this denominator missing that this denominator has? Remember, x squared means x times x, right? This one has 1x, we need to multiply by 1 more x. So I'm going to multiply the numerator by an x as well, which gives me 3x. All right, we're going to put this back together. My first numerator, once we added those two fractions, is 3x plus 2 over 3x, all over 2 plus 3x over x squared. This little line right here, well, any fraction bar, which actually has a name. Did you guys know the fraction bar has a name? And now I can't remember what it was. That was a Jeopardy question. And I was like, oh, I don't know that. And then I looked it up and now I've forgotten.
Ah.
So look it up. That bar has a name. Anyway.
I'm going to call it
any kind of division bar like this, that means division. That's a fraction. It means divide.
Is it the ventricle?
That's it. I was like, I knew it was something funky.
His name is Gary.
So this guy right here means divide. And remember, when we're dividing fractions, we keep it, change it, flip it. So we're going to keep it, change the division into multiplication, and flip it over. So I'm going to rewrite over here so I have a little more room. 3x plus 2 over 3x. Instead of dividing, I am now going to multiply. And then I'm going to flip this second fraction over. X squared over 2 plus 3x. Now remember, in multiplication, it's just top times top, bottom times bottom. If there's any common factors, you can cross out those common factors. Now, This is addition, 3x plus 2. This is addition, 2 plus 3x. Does order matter in addition?
No.
2 plus 5 is the same as 5 plus 2, right?
Yes.
3x plus 2 is the same as 2 plus 3x. So these guys are actually common factors and can cross out.
Oh my goodness.
X squared also means x times x. And we have a 3x down here. So what's going to happen with one of the x's here and one of the x down here?
It's gonna get rid of it, so-
These are also going to cancel out. That x is going to go away with one of those x's. So that means all that I have left in the numerator is an x, and all that I have left in the denominator is a 3. That was reducing the fraction down. That's the simplifying that we worked on last lesson.